Assalamualaikum warahmatullahi wabarakatuh.
My name is Shofwan Aulia.
My name is Maftuh.
Today we will learn about super hexagon for Identities Trigonometric.
So let's see the video.
What the super hexagon does, it really helps us remember all the trigonometric formula and the identities we have seen so far. Yes, it does. It's a simple hexagon which do like this. All we need to do is join all the opposite vertex, and that gives us three diagonal. We write the number 1 in the center. It's still difficult to believe that one hexagon can lead us to so many formula. To know the formula, we give the sig function. Name 2 is of sig vertex, but there is particular way in which we need to write it with to start writing from this vertex. How we write the sig function at the sig vertex? We just need to remember one formula which we have already seen. Tan is equal to sin by cos. We have used this formula like a zillion times. Now tan is equal to sin by cos. We start at this vertex and write tan sin cos. In the clockwise direction, tan sin cos. Now three function and three vertex remain. We write cot opposite to tan. Remember, cotangent opposite to tangent. What remains is cosec sec. We draw a vertex line through the center of hexagon. We will have 3 vertex on the left and 3 on the right. So to remember what written on this vertex, just remember that we have our function starting with c on the right side. So we write cosec here, and what remains is sec. That all you need to remember. About how the super hex has to be drawn, 3 diagonal joining the opposite vertex, the number 1 in the center, and the 6 function at the vertex. So let's draw the super hex on the next page. A hexagon with 3 diagonal joining the opposite vertex, the number 1 at center, and is equal to sin by cos, that opposite to tan cosec. Here sin all the at c are on the right and the remainder is sec. To understand the first set of formula, let's try going around the hexagon in the clockwise fashion. We go like this. This tells us that tan theta equals sin theta by cos theta. Well, that's how we started making our hexagon. Now let's see the next three functions in clockwise direction. Test 3, this tells us that sin theta equals cos theta by cot theta. The first one equals the second one by the third one, and take the next three functions clockwise. First equals second by third. Cos theta equals cot theta by cosec theta, and if we take the next three functions, we can say that cot theta equals cos sin theta by sec theta, and we will get the two more formally if we go clockwise. Cosec is equal to sec by the tan, and sec is equal to tan by sin. Wasn't that simple? One hexagon and six formula without any effort grid, but what if you forget that you had to go clockwise and you go anti-clockwise? Is that, let's say you started like this in the anti-clockwise direction. Don't worry, the pattern still hold true. First will equal second by third tan theta. Equals sec theta by cosec theta. First equals second by third. If we take these three functions anti-clockwise, we can write sin theta equals tan theta by sec theta. If there's 3, then cos theta equals sin theta by tan theta, and the list goes on whether you go anti-clockwise or clockwise. First will always equal second by third. We can easily get 3 more here, 1 simple hexagon and 12 formula. Is that all? No, there's more. Let's draw the super hexagon on new page. We draw the super hex and write a 1 in center. Tan is equal to sin by cos, cut opposite to tan. As we have all c on the right, we write a cosec here, and what remains is sec. In the previous set of formula, we did not use the one which was written in the center. Let's see why it is placed like this. If we multiply the function at opposite vertex, we get a 1. This multiplied by this equals 1. Sin theta multiplied by cosec theta equals 1. This multiplies by this also gives us 1. Cos theta multiplied by sec theta equals 1. And this multiplied by this also equals 1. Tan theta multiplied by cot theta equals 1. So when function are diagonally opposite vertex are multiplied, we get a 1.
Next, we draw the super hex. Write number 1 in the center. Tan equals to sin by cos, cot opposite to tan, and cosec here, since all c have to be on the right, and what remains is sec. Take 3 continuous functions in the hexagon, like tan, sin, and cos. Tan multiplied cos will give us sin. So if 3 continuous functions taken The product of the first and the third function result in the function between them. We can say that tan theta multiplied by cos theta equals to sin theta. Take these three functions for example. Cot theta multiplied to sec theta give us cosec theta. Even sin theta multiplied cot theta give us cos theta, and so on. First term multiplied the third term will give us the term between them. Okay, for the next, let's draw the hex again. Now, focus on the function at diagonally opposite vertices, sine and cosec, cos and sec, cot and tan. They are reciprocal of each other. Look at this row. This row tells us that sine theta is 1 by cosec theta, and this row tells us cos theta is 1 by sec theta, and this row tells us that tan theta is 1 by cot theta. If row is drawn like this, we even say that cosec theta is 1 by sin theta. So remember, function and diagonally opposite vertices are reciprocals of each other. Let's draw the superhex again. Do you remember complementary angle? Yes, two angles are complementary if their sum equals 90 degrees. And trigonometric function has a special relation with complementary angles. You get this row. What does it tell us about sine and cos? It tells us sine of theta equals cos of 90 degrees minus theta. This horizontal row tells us that sine of an angle is equals to cosine of its complementary angles. Similarly, this row tells us that tan theta equals cos of 90 degrees minus theta, and so on. If the row is drawn this way, it will tell us that cot theta equals to tan 90 degrees minus theta. So, a horizontal row tells us that one function of an angle is equal to the other function of its complementary angles. Okay, for next, let's draw the superhex again. Look at the superhex. There are 6 triangles formed inside. Focus on 3 this one. So here we go clockwise within each of triangles starting with top left position. Like this. Sine, cos, and 1. This gives us one very important identity. Sine square theta plus cos square theta equals 1. Let's go clockwise these triangles. 1 plus cot square theta equals to cosec square theta. If we go clockwise this triangle, we get tan square theta plus 1 equals sec square theta. This row can also be drawn anti-clockwise from the bottom of the triangle like this. The only difference is that there will be a minus sign before the second term. So it will be 1 square minus cos square theta equals sine square theta. And if like this, we can get cosec square theta minus cos square theta equals 1. And like this, we can get sec square theta minus 1 equals to tan square theta. Thank you for watching our video. Bye.